Okay, so this is Chapter P, Section 9, and we're talking about linear inequalities and absolute value inequalities. Now, because different textbooks use a different notation, I just want to clarify some of these symbols here. Now, the brackets and the closed dot mean the same thing as equal to, and then, or greater than and less than or equal to. And parentheses and an open dot mean the same thing as not equal to, so strictly greater than or strictly less than. And this chart down here gives us a lot of good information here. Before we get to the chart though, just a reminder, if you multiply or divide by a negative with an inequality, you must flip the direction of the inequality. Even some of my best students every year make this mistake and forget to do that. So just remember that you've always got to flip the direction of the inequality if you multiply or divide by a negative. Now this chart here gives us a lot of good information. If I have x greater than a, then this is what that looks like in interval notation, this is what the graph will look like, and this is really what it means in words. And so you see a lot of examples here. I'm not going to go through each and every one of them, but I recommend you look through them and see what each of these things actually means. Now at the bottom there's a little note here that says, remember you need to be able to do this in set builder notation as well. And we've actually already seen set builder notation this year. Remember, it's if you have something like this, and we have x such that x is, and then we have a description of x. X is greater than 5, or whatever your description might be. So that's set builder notation. Let's go ahead and look at the next page. Let's start out with an example here. We've got an inequality and we want to try and solve this. Now here we have some fractions here. We don't have any variables in the denominator, so we don't need to worry about that. And because of that, we can just multiply by what our common denominator would be, which in this case is 12. And then we're going to go ahead and reduce here. So 4 and 12 reduce to 3 and x plus 3 greater than or equal to, and the 3 and the 12 reduce to 4, x minus 2, plus 12 and 4 reduce to 3 and times 1. And we want to distribute and simplify things here. So on this side we have 3x plus 9 greater than or equal to 4x, and then 4 times negative 2 is negative 8, plus 3 is negative 5. Adding 5 to both sides, subtracting 3x from both sides, we get, let's see, 14 greater than or equal to x. And so that's our answer written as an inequality. If we write it in interval notation, x is less than or equal to 14. So that would be negative infinity to 14 and then include 14. And then to graph it, all I need to see is the number that we're looking at. So in this case that's 14, and we're shading on this side because it's negative infinity to 14, and then you need to make it clear whether it's a bracket or a parenthesis. And that's what our graph looks like. Now we can also look at compound inequalities, and that's where we have two inequalities joined by the word and or the word or. Now if it's joined by the word and, that means we're shading in between. So in this case we have negative 1 and 3, and x is both greater than negative 1 and it's less than 3, and so we're shading in between these values here. And I want to have a bracket on 3, and I want to have a parenthesis on 1. Now for this one, we have negative 1 and 3, and it says x is less than negative 1 or x is greater than 3, because it can't be both less than 1 and greater than 3. And again, we want to make sure that we use brackets and parentheses. So I have a bracket here, and I have a parenthesis here. Okay. Now let's look at solving absolute value inequalities. So if I have an absolute value inequality, first we want to get the absolute value by itself. We want to write two inequalities. The first inequality, all we're going to do is remove the absolute value and then solve. The second inequality, we're going to remove the absolute value, flip the direction of the inequality, and then multiply the side that didn't have absolute value by negative 1. And then we can solve. And then we're also going to graph. And I know that's a lot of steps, so let's go ahead and start going through an example first. So here we have negative 3 times the absolute value of 2x plus 6 plus 9 less than negative 15. So let's subtract 9. And negative 15 minus 9 is negative 24. And then we're going to go ahead and divide by negative 3. And remember that when we divide by a negative, we've got to flip the direction of the inequality. And now we've got absolute value of 2x plus 6. And the absolute value is by itself now, so we can write two different equations. So I have 2x plus 6 greater than 8 and 2x plus 6 less than negative 8. So flip the inequality, multiply by the negative 1. And now we can solve both of these inequalities. So subtracting 6, we get x is greater than 1. And then subtracting 6, we have 2x is less than negative 14. And then dividing, x is less than negative 7. And now graphing this, we have negative 7 and 1. And x is greater than 1 and less than negative 17 or negative 7. And we've got parentheses on both of these. And so that's what the graph would look like. And we can also write this in interval notation. We have negative infinity all the way to negative 7, union 1 to positive infinity. And that's our solution. Okay. Now, in your textbook, there's a really good summary at the end of Chapter P, and I would really encourage you to go over that as you begin to prepare for the Chapter P test. And that is the end of Section 9 and the end of Chapter P.